Hello students, welcome to samclasses. We got a bit delayed in bringing this video, but we'll try to make sure that the upcoming videos are on time. And since we are a bit new to the online setup, a bit due to the audio issues and all that, we got a bit delayed, but now we are progressing a bit more faster. So we'll try to bring up content, the quality content that we have promised in the time specified, and we promise you by 15th of August, all the materials and all what we have promised will be delivered to you. Now, coming up with this chapter, let's try to understand what is there in this chapter. Students will be going from in-depth to the advanced, but in few cases where things are too easy, we'll try to go a bit more faster because time is a bit less and we are preparing for KCT, not PU. Now, so here what I want you to do so that you are able to get the maximum 100% out from this video crash course. So try these 4 things. Now it is very important if you really want to benefit from this video crash course, which we have really worked hard to bring it live to you guys at free of cost. So please do help us, do support us, like, share and subscribe. It helps us a lot. Now let's see. And wherever you are having doubt, do comment it, put up your doubts. We'll work hard and we'll try to rectify from that doubts. Okay. So let's see. KCET KCET 2021 Mathematics. So we are doing the first chapter, matrices and determinants. In this topic, in this video, we'll be covering about the chapter matrices. So we already know the weightage of the chapter around 5 to 6 students. So as we can see, around 5 to 6, maximum it can go 7, minimum is 5. So a very good weightage and the chapter is damn easy. So students understand chapter is easy, weightage is high. So we can't leave it, okay? Now, let's go and start. Now, how to get the max or 100% benefit from this crash course? So first, before starting the video, before switching it on, if you are here till now and you're listening, take a pen and a paper or a notebook and a pen so that you can note down everything, okay, and you can get the max benefit out of this. The first thing and foremost thing, the most important is pen and a paper. Second thing is you have to make video notes, you have to make short notes along with the video. Second thing is very important, you have to make short notes along with the video. Third thing, students, pause the video whenever you are having a doubt. What do you have to do? Pause the video whenever you are having a doubt and note the time and put it in the comment section that at this point, this topic, I'm having a doubt. We'll work it out and we'll try to provide something on that. Or you can join our WhatsApp group. The number will be given down the description box. So you can check the WhatsApp group. You can put your, you can put your doubts on the WhatsApp group and we'll try to make some videos on that. Fourth, after going through all the video, we have included all the important concepts along with the formulas that we have promised. Now, nothing in KCET Maths will come apart from this. So don't worry, put your hard work, write down everything. And the next thing what you want from you students, if you're really dedicated and sincere and you really want to score 50 plus, go through all the formulas and make sure that all of these formulas on your fingertips and make sure that these formulas are on your fingertips. So that is the most important point because in the next section, when solved examples along with the PYQs, so you will be able to solve on your own. The formulas will help you a lot. Okay. Now, let's start the chapter. The first topic is pretty simple, kids. Matrix. Now, we all know about matrix. We have studied in PU about matrix. Now, in this video lecture, we can't do much of joking. Mostly when I teach, we are involved in funny ways. We discuss, we laugh, we do a lot of stuff. But here, kids, we have to be restricted. We have to be serious. Time is of the essence and we have very less time. It's a crash. And plus in 1.5 months, we are providing you with everything from top to bottom, from basic to advanced. So we have to be a bit serious, students. Now, matrix, as we know, or matrices, the plural form as we know, is nothing but just an arrangement. What kind of arrangement? Arrangement in the form of row and columns. What are these rows and columns? I'll make you understand. Or a rectangular array of numbers. It can be functions. It can be other stuff also. Now, numbers can be a real or a complex also. Now see, we already know that this matrix is denoted by a capital letter. First, we denote it by capital letter. Okay, capital letter. Second, the inside elements are denoted by small letter. So these two things are pretty basic. Now, this horizontal one is nothing but your row. So a lot of students, they have doubt, sir, what is the row? Okay, we get confused between rows and columns. Okay, thus the sleeping line is the rows. So this is the row 1. You can write it as row 1. This is nothing but row 2. You can write it as row 2. There's nothing but row 3. So we have 3 rows in here. Okay, and what I told you, the standing line is the column. So this is nothing but, or the vertical, we can say it is a column. So this is my column 1. Now, in case if there is a bit small spelling mistake here and there, do ignore it. I'll try not to make it. Okay, column 2, this is one column 2, and this is our column 3. Okay, students, so carefully note it down. Very important point from here is sleeping line. Okay, is your sleeping line is your row, and standing line is your column. Standing line is your column. Okay, so very important. Now a lot of people we see, sometimes they say row, you can extend it like this. So sleeping line horizontal, you can write it like this row, and column you can use like this also. So whichever way suits you, you can take that one. Okay, so what we have seen here, students, is we had 3 rows, 1 row, row 2, and row 3. So first in a matrix we write the number of rows. The order we write as number of rows into the number of columns. Number of rows into number of columns. So we have 3 rows, 3 columns. So that's why we have written 3 cross 3. Okay. Till here any difficulty? Do comment it in the comment section or in the WhatsApp group. Okay. Next part. So now we know about the rows and columns. How do we show it? How do we denote it? This either in a box form, we put the array of elements, or like this, a big, what do you say, parenthesis. Now, matrices are denoted by, a matrix we denoted by capital letter and its element by small letters. This I denotes the number of rows and J denotes the column. So if this first element A11, so the first one denotes the first row, that it is of first row, and the next one denotes that it is of first column. So this element is belonging to first row, students, and first column. That's why it is written A11. Understand, very important. Now next one is A12. How we can say A1 means what, students? That it is belonging to the first row, and 2 means it is belonging to the second column, students. So very simple. Okay, so the last element, let's see the last element, M rows. Total we have M rows, students, so that's why M here, and we had N columns, so that's why N, AM into N. Okay, so very important. So what is the order of a matrix? M cross N, where M stands for the number of rows and N stands for the number of columns. So very simple in this, nothing was in this. How do we denote it? Capital letter, elements inside by small letters, and then each element, how do we write it? We got to know it. Let's see a question. So the first question is very simple. A matrix is given to us, and they're telling that the matrix contains how many elements? 8 elements. Now they're telling that what are the possible orders? Very simple, students. So it can be either what? The number of elements is always equal to the total number of elements is always equal to what? The rows into columns. You multiply the number of rows with the number of columns, multiply the number of rows with the number of columns, you'll get the total number of elements. So you can have 1 row and you can stack all the 8 elements in 1 column. You can have 8 columns, sorry. 1 row, 8 column. You can take 8 rows and with each row 1 element. You can take 2 rows and 4 elements in each column, or 4 rows and 2 elements. So total we have 4 ways of doing this. Okay. So the order, possible order is how much? 4. Either 4 into 2 or 8 into 1 or 2 into 4 or 1 into 8, students. So very simple question. What is the total number of elements if it is given to us? That is equal to the number of rows into number of columns. So just we'll do all the factors and you will get it. Okay. Now, coming to the next section. Now in the next part, we'll see how do we construct a matrix. Now sometimes they'll give you a formula kit. Okay, so what they will do, they'll give you a formula. Now that formula will be based on, it can be anything. Okay, so here they have given you modulus. We already know what is a modulus. What is the modulus, students? If you don't know, modulus, what it does, if I have modulus x, it always brings the positive value outside. What it does, it always brings the positive value outside. So mod x, if you see, it can be represented as x when x is greater than or equal to 0, students, and minus x if it is negative, you put a negative sign when x is less than 0. Okay, so here they have given a very simple question, students. A of ij is nothing but mod of I minus j, okay, divided by 2. So now first element is what? 1 1. We have to make a matrix of 2 rows and 2 columns. So how it is like that? This is like this. So how many elements will we have? A11, A12, A21, A22. Okay, so now the first element A11, how we will find it out? Put in place of I1 and in place of J1. So 1 minus 1 is how much, students? 0. 0 by 2 is always also 0. So the first element we got 0. A21. So 2 minus 1 by 2. So that is equal to what? 1 by 2. Correct? Now A12. So 1, I is 1, J is 2. So 1 minus 2 by 2. So that is equal to half. Now it was minus half since modulus is there. What is the function of the modulus? If a number is negative, just bring out the positive. A22, it is equal to 2 minus 2 by 2. So 0, 0 always. Now 0 again, it will come out like as it is. So what we got the matrix, students? 0, half, again half, again 0. Okay, so this is the matrix A. We can write it as A is equal to this. Clear? Pretty simple. These are all you have learned in PU. Just going a bit in depth and slowly we'll start making the courses a bit faster. Okay, so wherever you are having a bit doubt or you want to make it a bit slower or anything else, do put your comments on the comment section because we read it dedicatedly and we try to reply most of them. Okay, next. Now the second thing what we'll be talking about is the types of matrices. Now here among that, the first thing is the row matrix. Row matrix is nothing but just one row. Okay, a matrix which is having one row. Now it's just a number of columns, as many as you put it. Okay, it can be one, it can be two, it can be many, it can be infinite. Okay, so whatever it is, if the rows number is one, that is a row matrix. The same way we can define column matrix, students. What is column matrix? If the number of columns is one. Now what about the number of rows? So there is no condition on the number of rows. You can take it as many as you want. Okay, the column, the number of columns should be one. Apart from that, no else condition. Okay, so I can make it like 1, 2, 3, 4. How many rows I have, students here? 4. So I can take it if I want. Somebody says, sir, I want to take a 1, 2, 3, 4, 5, 6, 7. So I can write it as 7 rows here and 1 column. So this is a column matrix. Now coming to the next type, 0 slash null slash void. Now a lot of people, they say 0 matrix. A lot of people, they will say null matrix. A lot of people, they'll say void matrix. So don't get confused. All three things belong to the same thing. They all point to the matrix where all the elements are 0. Now a lot of students, they have a confusion. Sir, what if few more elements are 0 but not all of them? Then it is not a 0 matrix. All the elements A of ij is equal to 0. Any order, students, doesn't matter, 3 cross 4, 4 cross 3, whatever order, doesn't matter. If all the elements are 0, directly we can say it is a 0 slash null slash void matrix. Coming to the square matrix. Now, the moment we say square, we picture around having length and breadth as the same thing or both equal to a side. So here also it's same thing, students. The number of rows, it will be equal to the number of columns. What is a square matrix? Pretty simple. Always keep your definition too simple so that it becomes very easy for you to remember it, to understand it for longer time and to keep it or retain it. So number of rows equal to number of columns. That's it. So the order will remain same. So somebody will say, sir, n corresponds to, what is it, the number of columns, m corresponds to the number of rows also. Simple. So here it is 3 rows. We can see the first row, second row, the third row, the first column, second column, and the third column. So the order is how much, students? 3. Okay, 3 rows, 3 columns. So the order is 3. Very simple. Now in here, one very important concept. Sometimes, a lot of times, it has been asked in KCT also. What is the trace of a matrix, students? What is the trace of a matrix? Now this word trace, the moment you hear this word, ring a bell in your mind that it is nothing but the sum of the diagonal elements, nothing but the sum of the diagonal elements in a square matrix. So what is a trace of a matrix B or trace of any matrix, students? Sum of the diagonal elements in a square matrix. So what do you need to keep in mind? This one, the sum of the diagonal elements in a square matrix. Again, say it if you want while writing the notes, do write these shortcuts, okay, and do say it while writing, so you'll understand more better. And wherever you're having doubts, you can join our WhatsApp group or you can put in the comment section. Along with the time, we'll try to work hard and we'll try to make something on that so that you're able to understand in a more better way. Now, if I'm teaching a bit fast, so do tell me, we'll try, or you can go a bit slower in the video. You can pause it and go through once again. And because we have very little time, students, and we have to cover a lot, we can't miss anything, so that you students have the ability to attempt everything and you can score 50 plus in KCT. So we'll work hard. We'll try to give you the best we have promised. Okay, let's see. So again, let's recap it. What is the trace of a matrix, student? Nothing but sum of diagonal elements in a square matrix. What is it again? Sum of diagonal elements. What are these diagonal elements? These are the leading diagonal elements. Okay, where I is equal to the number of rows equal to number of columns. See B11. Row and column are both same, B22. Row and column both same, B33. Row and column both same. So these are the diagonal elements, students. Okay, and if we add them, sum means what? If we add them, we'll get the term called the trace of a matrix. Okay, so nobody will be scared by listening to the word trace. Now you know it. Okay, any doubt? Put it on the chat section or put it in the comment section. Now next is diagonal matrix. Students, what is a diagonal matrix? Very simple. These are all categories of square matrix. Now a square matrix, okay, is a diagonal matrix if all its non-diagonal elements are 0. So what we have done, students, we have kept all the diagonal elements and the rest we have made them 0. So when such condition comes where all the rest elements are 0, leaving the main diagonal elements, then we say it is a diagonal matrix. Okay, it can be order 1, it can be order 2, it can be order 3. Again, understand in simple words, what is a diagonal matrix? A square matrix is called a diagonal matrix if apart from the diagonal elements, all the elements 0. So what you will remember in mind, apart diagonal elements will be there, apart from that rest all 0. Diagonal elements will be there, rest all elements will be 0. Pretty simple, nothing much in that. Okay, don't get confused. Whenever it is B of ij will be elements will be there, rest all if it is not equal to. Now a lot of people, we can write it in simple way like this also. It is a diagonal matrix if B of ij is equal to 0, means the element is equal to 0 when I is not equal to j. So it means what it's telling is for the I and j equal will have elements, for the rest others they all will be 0. So you can understand in more simple words, the diagonal elements like 1, 1, 2, 2, the where I is equal to j, there these elements will be there, except them all will be 0 students. Except them all will be 0 students. Okay. Now, coming to scalar matrix. Again, it has to be first a diagonal matrix, and diagonal matrix means it has to be a square matrix. So that square matrix, from their diagonal matrix, and then if all the diagonal elements of a square matrix is equal to some scalar value, let's say k, so then it is a scalar matrix. So nothing condition, a diagonal matrix. So you made these elements are there, you just make them same. Like let's say 3, 3 and 3. So all of them is what? Same, either -2, whatever element you take, the diagonal elements has to be same, rest all elements will vanish, they will be 0. That is a scalar. Now you'll say, sir, what if the equal diagonal elements, means the diagonal elements which were equal earlier in the scalar form, I make it to 1. So it becomes an identity matrix, students, nothing more than that. So if you have a square matrix, first condition is square, then diagonal means only the diagonal elements are there, non-diagonal elements we have made them 0. And then it is scalar means what? All of them are equal to one value, and if that value is equal to 1. See, very simple, 4 things are there. What are these 4 things? First, it has to be a square. What does you mean by square matrix? Again, row is equal to column. It has to be diagonal, means all the diagonal elements will be there, rest all will be 0. Rest all will be 0, students. Okay. Then it has to be scalar. Those diagonal elements has to be equal to some value. Okay, same value. Okay. So once you have done that and that same value will be equal to 1, then we get a what? Identity or unit matrix. So you can see here it is a square matrix, students. 3 into 3. Now, is it a diagonal? Yes, only diagonal elements are there. Very good. Now, is it a scalar matrix? Yes, sir. It's a scalar matrix. Why? Because all three of them, diagonal elements which are there, are equal at one value. Is it a unit matrix? Yes, sir. Because this equal value is equal to 1. Okay, very good. So, very important thing you need to understand here. Every identity matrix is a scalar matrix. Correct? But every scalar need not to be an identity. Okay? Like we can have a scalar matrix like 2, 0, 0, 0, 2, 0, and 0, 0, 2. Now, this is a scalar matrix. Very good. Because it's a diagonal matrix. Okay? And it's what do you say, the values are same, but it is not a identity matrix, as the same values, equal values, they're not equal to one, student. So very important, try to understand, very important. Identity matrix is nothing but square matrix, which is a diagonal matrix, which is a scalar. All values, diagonal elements, are equal to what is one particular value, and that one particular value is equal to 1. Now, singleton matrix, only single element, nothing more than that. Okay, row and column will be equal to 1, and it has only one element. Okay, next, coming to triangular matrix. A square matrix is said to be triangle if the elements above diagonal either 0 or below is 0. Simple. So what is it? Triangular. If above it is, see here we can see that below ones are all 0. So it is a upper triangular. Now here we can see that above one is all 0. So it is what? A lower triangular, because the elements are in the lower triangle. Correct. Here the elements are in the upper triangle. So that's why it's known as upper triangular. Clear? Very simple. Coming to the next, a recap section. We first read what is a square matrix, where row is equal to column. Then we have two types, one triangular and one diagonal. In the diagonal, only diagonal elements were there, D1, D2, D3, let's say, and the rest were all 0. And that is divided into two parts, students. Scalar one, where the values were what? Equal to some value, like let's say k. That k can be anything. And then we have the second part, the unit matrix. Okay, where in that case of unit matrix, the equal values were equal to 1, students. So this part was done. Here we have upper triangular, where above the diagonal elements were there, a triangle was formed. Here below the diagonal elements are there and triangle is formed, that is lower triangular. So this is the recap of the whole section. Clear, students? Let's move on to the next section. Students, let's now understand the next part. Very simple. Equality. Two matrix A and B, they're said to be equal if they follow two conditions. They're said to be equal if they follow two conditions. What are these conditions? First, order same. First, order same. Very simple. They are of same order. Whatever the order, then only we can do anything. So first, their order has to be same. And the second part is, what is that, students? That each and every element of the matrix 1 should be equal to matrix 2. So two matrix 1 and 2 are equal if they have same order, students. Very simple. And second thing, if each elements are equal. Okay, and their order is also equal, means the first element of here should be equal to the first element of the other one. So don't get confused. Just equal means what? Each and every corresponding elements are equal. Means this first element will be equal to this second will be equal to this third will be, let's say, equal to this, and this fourth will be equal to this. Okay, students, let's come to the next part. So if you see this example, students, first matrix is 1, 3, 1, 2, 3, 4, and the second one is 1, 2, 3, 2. See, the last element was not equal. So though they are of same order, they first satisfy the first condition. It was correct, the first condition, but the second condition was wrong, student. Not all the elements were equal. We need each and every element where it has to be equal. Let's see a simple question. Now here I have taken very less of question. This is more of a conceptual plus formulas based lecture. The second part will be uploading by today or by tomorrow max. It will contain the solved examples from NCERT, from Exemplar, and from the best books available in the market. Now, let's say these two matrices are equal. So they're telling that find the value of A, B, C, and D if both are equal. So very simple. The moment the both are equal, we'll first check the order. Order same, 2 into 2. Here also order same, 2 into 2. Done. Second part, each of this element will be equal to the first element of first matrix will be equal to the first element of the second matrix. So A plus B is equal to 2. Very simple equation. Now, and A minus B, we can make it as 6. So A minus B is equal to 6. Now, we all have studied in the smaller classes what the how to solve these kinds of simple equations. So we just add them. So we'll get 2a is equal to 8, and then from there a is equal to 4. Similarly, we can do c plus d is equal to 4, and we can do c minus d is equal to 8. So the moment we do, just add it up, dd will be cancelled. 2c is equal to 12 and c is equal to 6. So nothing is there in this. Okay, very simple. Let's move on to the next section. Operation of matrices. So basically we'll be discussing about the major 4 operations. What are those? First, addition. How do we add two matrices? Scalar multiplication means multiplying by a value scalar quantity like k, which is not equal to 0. Now, matrix multiplication, when you have two matrices and you're multiplying it, then in that case, how we do it? Difference of two matrices. We have a matrix A, a matrix B. Then if we subtract, what do you mean by that? So let's see from the addition part. Let's say we have two matrices A and B, and we wanted to add it. So first is A of ij, first one, and the second one is B of ij. So the addition is very simple. First we have to check that they can only be added if they are of same order. Again, they can only be added if they are of same order. And the moment we know they are of same order, what we do? We just add them A, B, C, and D. This one plus is not there. E, F, G, and H. So corresponding is at the first element is added of the first matrix to the what is this first element of the second one. A plus E, B plus F, C plus G, and D plus H. Okay. So what we are doing? The first element of here is added to the first element here, and we got this. Second element of here is added to the second element here, and we got this. Third element of here is added to the third element of this. We got it. Fourth element added to the fourth, and we got this. Okay, students. So each and every element is Now coming to the next part, the scalar multiplication. Okay. In this scalar multiplication, if you're multiplying a matrix with some scalar quantity k, then that scalar quantity is multiplied to each and every element. Okay. Now a lot of simple questions came in KCET. Okay, a lot of times. So students don't get confused because indeterminate, that is a different thing. In matrices, it is a different thing. So whenever we say 3 times of a matrix A, we mean that each and every element of matrix A is multiplied by the scalar quantity. Here in this case, we talked about is 3. Okay. Now, when we talk about the different students, again, we have to check that the order has to be same. We can't add or subtract until unless the order is same, students. Once we know that, we can just, subtract both the matrices. Okay. Any difficulty, do write us on the comment section with the time specified of the video, so we can put our hard work and we can remove that issue. Now coming to the next part, students, the properties of matrix addition. Very simple properties, but sometimes they give us in different forms, so we get confused. So we should know it. Commutative, we all know, if we add first to second or second to first, it's the same thing, students. Now associative means if we add A and B first and then we bring C, then what will happen? It will be same as adding B and C first and bringing A. So that is known as associative. What is additive inverse, students? A, and then if we add with some other matrix such that it gives me a zero matrix. So that is known as additive inverse. So for in case of A, the additive inverse is what? Minus A. Very simple. Now additive identity, if for a matrix, if I'm adding something so that the matrix again itself appears, so that is known as additive identity. And here in this case is zero matrix. So A plus a zero matrix is equal to that same matrix. Okay. Now, next is scalar multiplication. Just now I told we have a matrix, we multiplied with k. Each and every element will be multiplied with k. So very important, students, try to make it a point. Okay. And you don't get confused in the exam. You have to be fast also, and you have to do it properly. So no confusion here. Each and every element is multiplied, not just one row or just one column. Okay, all elements. Now properties, you can multiply it like same, different. K will multiply to the first matrix and the second. If I have two values, I can do like this: first time with first value plus the second time with second value. Or if I have two values, K and L, and then I'm multiplying with A, it's same thing as you multiply the whole thing with K first and then with L. So no problem in that, students. Okay. Now, so we can take a simple example of this, like let's say 2 into 3 into A. It's same thing as you take 2 into and then make 3 times of that matrix A, and then you will get 6A. Okay, students? Now, coming to the matrix multiplication, a very important thing, but very simple. Try to understand. It's very simple, students. Now we have a matrix A of order m cross n, and we have another matrix of B, order P cross Q. So first thing and foremost thing we need to know, when is it possible? Can we multiply any two matrices like as it is? No. We have to check if they follow certain conditions, then only we can multiply. And what is that condition? So most of you will be knowing this condition, but still I'll say the number of columns of the first or the A will be equal to the number of rows of B. The number of columns of A is equal to the number of rows of B. Okay, students, so very simple. The number of columns of A is equal to of the first one is equal to this part is equal to the number of rows of this one. Okay, so you can make it, and the matrix which is formed will contain the rest two left ones. So M into Q. Okay, students, again. Let's recap it, students. Matrix multiplication, we have two matrices A and B, and A is of the order M into N and B is of the order P into Q. So you can't multiply them directly until unless you do a checking. And what is that check? What is that rule? Understand it. The number of columns of the first one or the number of columns of A here in this case is has to be equal to the number of rows of B. If that is happening, then only we can multiply. Otherwise, we can't multiply. So very important, students. The columns of the first one should be equal to the row of the second. The second thing apart from that, students, what is the new matrix form that will have the row of the first one and the column of the second one? Okay, so very simple. So you can make it like this: M into N, P cross Q. So this and this has to be equal, and the formed one will be M into cross Q. Okay, you can make it like this. Very simple idea. Now let's say an example. A is equal to 1, minus 1, 0, 2, 3, and 4. And B is equal to another matrix 2, 7, minus 1, 1, 5, and 4. So now we want to multiply A and D. So very simple. First we have to understand what is the what is the order here of this matrix, students? 2 row and 3 columns. What is the order here? 3 rows and 2 columns. So if you can see, these two are same kids. So until unless these two are same, we can't do it. And the next what is left is 2 cross 2. So this matrix has to be of 2 cross 2. So what are the elements? A11, A12, A21, A22. Okay, 2 cross 2. Let's find the elements, students, and let's find the multiplication. Okay, so here we have in this case 1, minus 1, 2, and 0, 3, and 4. And here what we have here is, let's change the color a bit. Okay, now. So 2, 7, minus 1, 1, 5, and 4. So we have already checked that they are compatible for multiplication. So we want to find out what is the first value. So here let's make a big one. So this one A11 means first row and first column. So first row will be taking from the first matrix and first column will be taking from the second. And then what we'll do, each element corresponding will be multiplying and adding them. So 1 into 2 plus minus 1 into minus 1 in second of this into second of this plus third of this, the first row element, plus third of the first row column. So we got here 2 plus 1 plus 10. So how much, students? 13. Pretty simple. A12 means first row will keep it here, but this 2 stands for the second column, students. 2 stands for what? The second column. So what we do? 1 into 7 plus minus 1 into 1 plus 2 into minus 4. So how much you get? 1 into 7, 7, 1 minus 1 into 1, minus 1 plus 2 into minus 4, minus 3. So how much you are getting? Minus 9 plus 7, students. So minus 2. Very simple, minus 2. Second one was what? 2, 1. So second row from the first one. And the column will be the first column. So very simple. So 0 into 2, again gone, plus 3 into minus 1, plus 4 into 5. So how much you are getting, students? Minus 3 plus 20, that is equal to 17. A22 means second row from here and second column also from here. So 0 into 7, students, plus 3 into 1, plus 4 into minus 4. So that is pretty simple. So 3 minus 16, that is equal to minus 13. So what you have done, students, if our term is, let's say, AMN, so what you have taken? Mth row from the first one and nth column from the first one, and then each corresponding elements, we multiply them and then we add with them. Okay? Clear? Done. So this is matrix multiplication. Now let's see some question. Now this question is for you students. Okay, pause the video here, try to solve it, and once you have done, do check the answer with the video. So we have a matrix A, that is A1, B1, A2 and B2, and we have a matrix B that is equal to C1, D1, C2 and D2, and now we want to find AB. So first thing what you have to check, students, is whether they are compatible or not. Correct? We always check everywhere we are compatible with someone else or not. So we check with the matrix whether we are compatible to multiply them or not. So it is also a 2 into 2, it is also a 2 into 2. So are they compatible, students? Very correct. Yes, you know it, they are compatible. And what is the new matrix form? That is of the rest to left ones. Okay, so done. So we already know what are the elements. So first we'll take the first one. A11 will be nothing but first row and first column. So that is equal to A1 into C1 plus B1 into D1. We got it? Okay, A12, that is equal to first row here and second column here, students. A1 C2 plus B1 D2. Very good, students. Now if you have got the same thing, very good, you have understood the concepts. A21 is second row from here, first column from here. So A2 into C1 plus B2 into D1. A22 is equal to A2 into C2 plus B2 into D2, students. Okay, so this is the answer. You have to put it here. If you got the same answer, students, you got it correct. Let's move on to the next page. Now, properties of multiplication. Now we know they're not commutative, students, because in very few cases it can be like AB is equal to BA, but in rest and maximum cases AB is never equal to BA. Okay, associative law. If I'm multiplying AB first and then multiplying with C, that is same as if I'm multiplying BC first and then with A. So same thing, no difficulty in this in the associative law. Okay, distributive also it follows. If I have A and then in bracket B plus C, so that is same as if I multiply AB plus AC. So no difficulties in this. Now this is very important, students, for your KCET part also. For matrix multiplication, if they say that AB, the multiplication of two matrices is 0, it does not guarantee, students, that either A is equal to 0 or B is equal to 0. Okay, so the moment they say this, they'll give you in the option form that the matrix AB is equal to 0. Can you say that A is equal to 0? You'll say no, we can't say that it has to be 0, or we can't say it has to be the B has to be 0. Okay, students, so be very careful in this. Next is existence of multiplicative identity. Very simple. If you multiply anything with I or a unit matrix of that order, you'll get the same matrix, okay, A only. So that is known as existence of multiplicative identity. What is cancellation of this? We use a lot, but we don't know how to do it or why do we use it. So if you see good books and from good properties books, you'll be able to understand from addition and advanced ones. I have picked up a few which is needed for the KCET part. Okay, so when AB is equal to AC, students, what we can do, we can cancel the left and left this side, and we can, but yeah, in order to cancel, we have to make sure that A is not equal to 0, students. Okay, and we can write B is equal to C. Now if I have DA is equal to CA, we can do right cancellation. A will be cancelled and B will be equal to C, and here also same case, students, A should not be equal to 0. Now the properties are done. Any doubt, put in the comment section, students.